Hi guys, nice having you again here on Will EduTech, and in this video we're going to be looking at the solution to question 5A, a typical geometry question, and it's taken from the CSEC Math Exam Past paper, January 2012. Now let's just pull this up a bit so we can have the question in its entirety. Now my friends, as the question states, the diagram below not drawn to scale shows two triangles, JKL, which we have here, the larger triangle, JKL, and MLP, which we have in the smaller triangle, MLP, with JK parallel to ML. And that's quite evident because on the line segment JK, we have an arrowhead, and on the line segment ML, we also have another arrowhead running in the same direction to show that these two lines are parallel. So when you see arrowheads on lines running in the same direction, that's an indication that those two lines are parallel. Okay guys, now it states that LM is equal to MP. All right my friends, so the line segment ML or LM is equal to MP. So obviously right away we see that the triangle MLP is an isosceles triangle. Alright, now it states that KLP is a straight line, and obviously here we have it, KLP, that's a straight line, and the angle JLM is equal to 22 degrees, and we can identify that JLM, the angle here at the point L, okay, 22 degrees, and the angle LMP is equal to 36 degrees, and we have it here, LMP, that angle here at the top, is equal to 36 degrees. And as we have already stated in previous lessons, that any letter that is in the middle, okay guys, that's where the angle is being formed at that point. So if you notice, the L is in the middle here, so the angle 22 degrees is being formed at the point L. If you notice, the M is in the middle here, and the angle 36 degrees is forming at the point M. Now enough said, let's quickly get into it. Given the fact that we have established that LM, or they stated that LM is equal to MP, and we know that this is an isosceles triangle. Okay, if they're asking us now to calculate, giving reasons for your answers, the measure of each of the following angle, and the first one, they want us to calculate the angle MLP, which is, and let's identify that MLP. So they want us to calculate the angle at the base here. Let me just copy this diagram so that we can see it a bit clearer. So now my friends, simply put, since we have established earlier that the triangle LMP is an isosceles triangle, then it simply means then the side MP, this side here, is equal to the side LM, that side there, okay? And another important thing to note is that the two base angles, since two sides are equal, then the two base angles, these two angles here at the base that I'm marking in, those two angles would be the same size also. So quickly we can calculate the angle MLP by saying, first I'm going to make a statement. Whenever I am calculating or introducing a variable, I always make a statement. Okay, so my friends, I have now introduced my variable. I've stated here, let x represent the sum of the base angles. Okay, so basically what I'll be doing, since these two angles are equal, then I can just simply subtract the angle at the apex, meaning the angle at the top here, 36 degrees, from 180 degrees to get the sum of these two angles. All right, so let's quickly get into that. So I'm going to say for part one, okay, for part one, let's move. We're going to say x must be equal to 180. And where do I get the 180 from? Remember, in any triangle, the three angles sum to 180, okay, when added. So I'm going to simply say 180 minus the 36 is equal to 144. 144 degrees. Okay, now we have to give our geometric reason, because for each geometric value that we calculate, we have to give a reason to back it up. Okay my friends, so the reason is angles in a triangle sum to 180 degrees, and I'm just going to pause the video and write that. So my friends, having the value of x, which is the sum, as we have stated, the sum of the base angles, meaning this angle plus this angle, alright, given the fact that it's an isosceles triangle and these two angles are equal, then I can say then the angle, let me change my color quickly, angle MLP is equal to obviously the sum of the base angles, which is x, divided by 2. And we all know that the sum of the base angles, it came up to 144. That's 144 divided by 2, which is equal to 72 degrees. So the angle here, MLP, would be 72 degrees. Also, the angle MPL across here would also be 72 degrees because both angles are equal. Hope that makes sense. Now we have to give our geometric reason for this. I'm going to pause the video again and write my reason. So there we have it, my friends, our two geometric reason to calculate the value rather for angle MLP. First, angles in a triangle, the sum of the angles in a triangle adds up to 180. That was the reason for part 1, and for part 2 now we divide the sum into 2 and we got 72 degrees, and our geometric reason is here. Base angles are equal in an isosceles triangle. Now let's move on to part 2, angle LJK. Now if you look carefully at the angle LJK, they're asking us to find the angle at the apex here, my friends. This angle here at the apex they're asking us to find. Now if you notice, they had stated earlier that the line segment JK and the line segment LM are parallel, okay, meaning that they are the same distance apart from each other anywhere along the lines you measure. All right, my friends. Now, given the fact that the line segment JL connects or it intersect the line JK, okay, and it intersect the line LM, okay, at the point L, and it intersects JK at the point J, then we have a pair of alternate angles, my friends. So it simply means then the angle that is here at the apex that they're asking us to find at J would be the same size as the angle at the point L down here. And if you notice, it is forming a Z, and alternate angles, another name that they use to refer to it as, are Z angles. Okay, my friends. So I can just pause the video and make a note of that quickly. So my friends, there we have it. The angle LJK, which is this angle here, LJK, the angle at the apex that they're asking us to find, must be equal to the angle MLJ, this 22 degrees here, as we have had it there. And the reason is that alternate angles are equal. Now, that's it. Easy, 2 marks. Now, again, they're asking us to find JKL. So this angle here, J at the top, K here, and L there. All right, so let's just mark that angle quickly. This angle at the base they're asking us to find. Now, my friends, if you notice carefully, since initially they had stated to us that the line segment JK is parallel to the line segment ML, then simply means then that this angle JKL that they're asking us to find, that I've marked in red, it must be the same size as the angle MLP, okay, this angle here at L that I'm also coloring in red, okay, because why? ML was parallel. They stated ML is parallel to JK. So basically, when you have a situation like that, we have corresponding angles. We have a pair of corresponding angles there. So I can say then now, for part 3, the angle JKL is equal to the angle, and it's equal to the angle MLP, which we have found earlier in part 1. This angle here, MLP, or 72 degrees right there, okay, is equal to the angle MLP, which is equal to 72 degrees. And our reason for that, my friends, and we can state it clearly here, our reason is that corresponding, so we say corresponding angles are equal, okay, corresponding angles are equal, okay. So that's the size of our angle JKL. It's 72 degrees. Now the final part 4, and let's just make a note of that quickly. Part 4, let's just work it out over here. Part 4, Now in part 4, they're asking us to find the angle KLJ. So let's identify that angle. The L is in the middle, so the point L they're asking us to find. So the angle KLJ is this angle here at the base now that they're asking us to find. Now just let me change the color a bit. The angle here they're asking us to find, the angle KLJ. So it would be that angle at the base of the triangle JKL that I'm coloring in black now. Okay, my friends. Now we had found MLP earlier. We had found MLP to be 72 degrees, and if you notice, my friends, this 72 degrees would be the angle at L here, and we have a 22 degrees here. So obviously we could just add these two angles, subtract them from 189, and we would have gotten the value for the angle at the size of the angle at KLJ. All right, so let's quickly get into that. So my friends, the angle KLJ is equal to, since they had stated that KLP is a straight line, we can say angles on a straight line are supplementary, or they add up to 180. So what I'm going to be doing, I'm going to be subtracting. I got this angle here to be 72, if you remember in part 1 when we worked that out. So I'm going to say 72 plus, and we got this angle here, they gave that to us, and that is a 22. Okay, so really angle KLJ is equal to 180 minus, and 72 plus 22, that will give us a 94. Okay, so that's 94, and 180 minus 94, that would leave us with an 86 degrees. Okay, but we can't stop there. Remember, we have to give a geometric reason. So now we have to state that angles on a straight line sum to 180. All right, or you could say angles on a straight line are supplementary. I'm just gonna pause the video and write that again. Hold for me. Now my friends, there we go. Here's our reason for the value of angle KLJ to be 86 degrees. Its angles on a straight line are supplementary. And just remember, another phrase for supplementary, you could always say angles on a straight line sum to 180. Okay, it's just another way of saying it. All right. Now, hope that was helpful. Feel free to subscribe to the channel so that you can get the latest updates from more videos. Bye bye.